So in this video, we will see how to analyze the results that we get from the LCS software model. So we'll focus more on the WTP pane, which is the wells to pump pane. And here is a list of all the products from fossil fuels as well as renewable energy. So I'll focus on ethanol. Ethanol, if you select ethanol, there's a drop down menu from ethanol which shows its production from various sources such as corn, which is first gen, and then a bunch of second gen feedstocks such as poplar, corn stover. So I'll focus on one from corn stover because I think it is related to the NREL model. So once you click on that, there will be a pathway which shows its production from corn stover, and then there are two different processes. One is gasification and fermentation. So for the sake of this model, we have selected just the fermentation pathway and not the gasification. So there is like 0% allocation to that. And once we get the ethanol, we transport it using the PING process, which is using barge, pipeline, rail, and heavy-duty truck as explained in the previous videos. So by double clicking on each of the modes, you can actually see how many miles and what is the share of each of the transportation processes. One thing to keep in mind is the product which is being transported heavily affects the emissions. So the density of ethanol affects the final emissions that are created, and it is very crucial to be exact, input the amount exactly to get the accurate results. Okay, so now we see that there are two outputs. We focus more on the second output, which is the one that is being transported using the 4 transportation methods. In order to get an accurate idea of what exactly are they accounting in for the emissions, we have to trace the pathway to its source. So we do that using by right clicking on all of these processes and see what exactly they have accounted for. So for example, in this process, we see what they have done exactly. So in this, they have just selected one of the pathways, that is fermentation pathway. So this value is 100 for fermentation. If you want to choose just gasification, then we would allocate 100 BTUs to gasification and make this 0, so that now the entire thing is shifted to gasification. But we want just fermentation, so we'll reallocate that to fermentation pathway. Now we move on to the previous, so we backtrack it to the previous process. So now ethanol via fermentation, we right click on that and we press edit this process. So now we have the exact process with us and all the ingredients in that. So corn stover, this quantity has to be calculated according to our process. So we have to, for self process, we have to create a data analysis file in Excel and then have all the numbers for our process which we built in our lab and input those. And again, the loadings, the solids loading, the yeast amount, the sulfuric acid amount, everything is inputted in this, but for our case we have to recalculate it for self. Then we see again backtrace it to the corn stover. So again, this corn stover is being manufactured, or like it is farmed, so we have to navigate to that pathway and we exactly know how much of emissions were accounted for while farming of corn stover. So we navigate to that pathway, and now here we see that there are 3 different stationary processes and 1 transportation process. In the stationary process, we could see that 100% of the corn stover is taken from constover collection, and the rest are 0, but we could change those in the data editor pane. For simplification, we'll just see the first pane. So in this, we can see that there are different ingredients which are involved as fertilizers for growing corn stover. So again, the nitrogen, phosphoric acid, potassium oxide, and corn stover. These are the ingredients which account for emissions while farming, and so this software really goes in depth of calculating the CO2 emissions and other pollutants. And even these, so for example, nitrogen, which is fertilizer, it shows that it takes into account the production of nitrogen as well. So it also takes into account the emissions went into producing nitrogen. Then we move on to the once we are thorough with the numbers in all the panes, we again move back to the ethanol plant and go and do the data analysis, like see how much grams of CO2 we are emitting from per ton of ethanol or per megajoule of ethanol. So once we click on the border of each process, the results appear on the bottom left side of the pane of the window. So the results are in the form of kg, CO2, VOC, CO, all the pollutants and the greenhouse gases, and they are per ton of corn stover, but this could be modified according to your preference. So it could either be energy, so energy, or like kilojoule of a corn stover, and you could get those emissions. So this is per kilojoule of corn stover. Now if you click on this pane, it will recalculate the emissions for the fermentation pathway. And now we have values for emissions which are which include the production of corn stover as well as the fermentation pathway. So these emissions are a total of this pathway as well as this pathway. And now once we click this one, like the next process, it accounts for emissions from the previous two and this one. So while data analysis, this is one important thing that you keep in mind. So now in order to analyze how much CO2 is emitted just during the fermentation, we open up an Excel file and copy paste the values. So we right click on the results pane and select copy all the values and paste it